Okay, audio check. 1, 2, 3. Sounds okay to me. So, oh goodness, here we are. Wonder why I always do this. I always crank out 5 days worth for the week, but I only work games 4 days. So 2 days. Let's see. Oh no, wait, that was right. That was 4 days. We've got Monday, Tuesday, Wednesday. All right, so today's Wednesday. There we go. Yesterday, we removed our last extension from our OpenGL shaders, which means we had to change the way that we look up our uniforms, and that's fine. I like the other way better, but let's keep the OpenGL strict and simple for now. Next game will be a little bit more fun. Moving screen space scaling calculations. Yep. So removed a bit of copy pasta there, so looks good. Slowly whittling away our technical debt. So I think today we'll address these two, which are really the same task, but with two different possible fixes. So let me see if I can pull up an example. Source TextEdit. So here I have a function that returns the text and the length of that text. Then I have a function that calls set text size, set text color, align our text. And all of those things are really just part of the text object itself. So why do I have these delegate methods when I could just expose this, which is what I did here, right? So we could literally delete all of this and then anything in the text object that I add, new features or whatever, just I have access to. Like, if I'm just going to pass through everything, I might as well just make the thing itself available. So that's one thought. The other thought is we don't want to give away what we're doing underneath at all. And so we should wrap everything up so that there's a layer between the user and the thing. So those are the two tasks for today. Is I got to decide which one to actually execute and then do it. So yes, Stravest, good evening. You have excellent timing on the Discord channel there. Well done. It's like you could set your clock by my stream there. Wednesday, middle of the week. I don't know why, but I'm having a hard time pinning down the day of the week. This week, some weeks I'm like ahead a day or behind a day. But this week, yesterday I thought was Wednesday, and today I feel like it's Tuesday. I'm just all off. But that's okay. So this tech debt actually probably won't take us very long. So we'll see what else we get up to while we're what else we get up to today. This one is more of just like a little refactor. It's good to keep a consistent time, I think. Yeah, that's what I hear. Also, just easier for me to block off my office and say, nope, from this time to this time, I'm unavailable to the kids and things like that. So, yep, consistency. It's actually something I've been getting after my kids a lot for. If you want to be fit and athletic and good at whatever your sport of choice is, well, consistency. You want to be smart. You want to learn things. Well, consistency. You want to have an audience on Twitch. Well, it's all about consistency. Ooh. It seems to come up an awful lot. So consistency is good, I think. Okay. So I think we'll probably blaze through our first item of tech debt here in just an hour, maybe. maybe an hour, because I'm leaning right now towards not using delegates and just exposing the dadgum child element. Because every time I then change text, I then have to add another delegate to our text edit. So why don't we just expose the text element? Same thing for integer SpinBox, right? Where is it? There we go. My camera's in my own way. So those are like text editing things, but now I have text size, and that's the only thing I allow us to change? Wow. So instead of adding a whole bunch of delegates here, why don't we just expose the text edit element and be done? I'm leaning towards that. And honestly, there's only one other class that even has this compounded component, and that is the button, which has a text, which again, look, I'm not exposing everything that you could do. So maybe we just oh goodness. Maybe we just expose the text element itself and call it done. That's it. We brought up our 3 classes that we really need to touch. I don't think anything else matters. Obviously, in the future, like we might do like a table or a dialogue pop up. Those kinds of things will eventually become a thing, but not this game. So I think that's it. I think I'm leaning towards let's just expose. So let's see here, journal. I just want to expose the child component and not delegate the methods. So so Travis, I think that consistency as much as possible overall in life is a good thing. Yes, in a lot of cases. However, I would also caution against too much consistency. Creativity happens when you are put under unique stress or when so let's take weightlifting for example. If you get into the same routine, you're always doing the same thing. That's great. That's better than nothing. But to get the gains to break out of plateaus requires you to do something extraordinary, right? You have to push through those limits. So, um, yeah, there's a balance. Like you need a certain amount of chaos in your life, but not much. Not so the very very creative types that have very chaotic lives, like they can't get anything organized and straightened away. I agree that's way too much chaos. But you also have the truly obsessive compulsive people who really can't change their life anymore. It's like wow, wow. So a little of both, but consistency is a better foundation from which to build. I think you can add the variation as needed. So yep. Balance and consistency. I like that. Now the reason I harp on my kids so much about consistency is because consistency is not yet a strength in their world. So if they had too much consistency, I would harp on them to get outside their comfort zone and push some boundaries a little bit. But that's not the problem I have right now. Okay. So unless anybody has deep thoughts about writing implementation and just using delegate methods to pass through, I think I'm against it in this case. I think it'll just make my life easier. Notes. Components with child components where appropriate should just expose the child element and not create unnecessary delegates. Change to child components, then don't have to be additionally exposed. with more code. Of course, some things should remain hidden and abstracted. Example, I think TextEdit has a color quad and a, let's be consistent here, and a text. The text should be exposed. The color quad should be hidden. So resizing the whole thing will cause the quad to update. Changing the background color causes the quad to update, but that's because the changes there relate also to the text. But text itself does not affect at all the color quad or the rectangles or anything. So we're going to do like when something is abstracted, like I think we may abstract away the color quad and call it like a frame someday. So we'll keep that abstracted for now and just expose the text element. Keep my API small. Sorry, I gotta open new gum here. I'm really looking forward to eating a ton of donuts in October. Gum is not my go-to, but all right, so what we're gonna do is we're gonna remove this and all of those and expose that, and that's basically it for TextEdit. So the text we can get from the text element, the length. Set text is already a thing we can do. Set text size, text color, and alignment. So this is why here we don't expose the color quad. We calculate the color quad rectangle based on this one, but that also affects the text. So, okay, I think that's it. Maybe somebody will come back and call this like set background color or something. Let's return the text object. Yeah. Okay, so that should do TextEdit, and then we'll see what comes up in the old compile. I did not save the to-do. There we go. Compile, clean, debug. We'll do a full clean first thing in the morning. Oh, yeah. If this only takes me an hour, I don't know what to do next. Maybe I don't know. We've got ideas. We've got things in our to-do list. So let me think while that's building. This one has 15 sticks of gum, and this one has 14. So I'll run out of these ones first. Interesting. Oh, interesting. I was using more of those than I thought. All right, only one thing to do. Okay, so that should fix those first four. This is gonna be a pretty mechanical operation kind of day. Okay. So that, in theory, should fix up all of int SpinBox. We do not need to clean. We just did clean. Oh, that's going to cause some other issues. Okay. One, two. Okay. Yep. Afraid this is mechanical day. Just go through the motions, let the compiler find all the issues. Text. Point to text. Okay. I can't see around my camera. Settings sync. I could swear we saved that. Okay. Okay, so we're down to sandbox scene. This is the kind of thing that I can actually write a macro for. So let's see here. Do I want to? Enter text 22. Let's change up my macro just a little bit. Before we go back to the other buffer, let's center this buffer. Okay. So this was 147 where we are at. Oh, interesting. It kind of worked. There we go. So maybe our macro is not quite right yet. Yeah, I'm not sure about that. Okay. Okay, refactor. Oh, that wasn't too bad. Text edit. Looks okay. Cursor width. We're gonna double that up, I think. Or just make it 1. Maybe we make it unscaling width. We can do that. You can always come back and change it if we want to. Okay, let's text edit. Okay. There we go. And then all this just goes away. And now whatever feature we want from text, we can put in our button. That is going to break a lot of things. Okay. So let's let the compiler find out where those all are. Find reference. It needs to pull up clean then. It's giving weird messages. All right. Okay, yes. Clean up, refactor, make life better. Yeah, Travis Roman in the chat yesterday got me thinking about writing a OS level abstraction layer so I can be cross platform pretty easily. Ooh, okay, this one's gonna take a little while to fix up, isn't it? We do a lot of things with buttons. Oh, darn. Right, F3, we're gonna select this one. Okay, that's not correct at all. Okay. Okay. We actually have to do this slightly differently. F3. Enter. 22. Center. Center. F4. So these set texts are all the same. Oops. What? I know why. There we go. Okay. if we search for error, search forward for error colon, return. So this one has not been done. Okay, so if we run this one, oh, okay. So let's edit that macro one more time. Before we search, we go to the end of the line. Okay. Did we not save in our macro? Control X, Control S, save. Okay, so. Okay, so if we go F4, setting text should all be reasonably reasonable. Set text size should be reasonably reasonable. Only for the buttons, not for the labels. Oh, label. The labels are already a text object, so. Okay, then boom. Well, that was easy. Did the about scene. Refactoring is really not that bad once you get macros figured out. Okay.
No, yeah, professional people. Professional people. How they got it somehow. Or you just see it's not.
All right, F4. F4, those all look good. Game scene. This one might have a few. Oops. Okay, run it. Yeah. When we get a text, that's when we mess it up. It should be fine. Fine, 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 fine. It's only when we get text that it complains at us. Well, boom. That should be all of those. With a little bit of macros, not too bad. I thought this was going to be worse. Hey, FitWriter. Hey, Pat. How's it going, everybody? Should we run things and just make sure it's still running? Probably. Probably should. Oh look, things are there. I don't think we broke anything. Okay. Yeah, so that refactor hasn't broken anything yet, so let's go to int SpinBox. Okay. There is a couple of questions that need to happen here. We can expose the text element, the text edit element, easy enough. Do we also want to expose the buttons so that you can do style things with the buttons? I'm leaning towards yes. Gives us more options later. Like, if I was making this as an API for general usage, I would be more about locking things down, but I think since I'm the only developer, and I trust me, I have much more on the let us expose things in a way that makes my job easier. Sometimes that means abstracting away and hiding information so I don't have to think about it. But in some cases like this, where it's like a style thing, I think it's going to be more beneficial for me to just expose the stuff. So I'm going to go with a text edit pointer. And then the buttons. Button, enter, button, and the decker button. And this actually doesn't look like it needs much refactoring, just set font size is really the only thing we can remove. So we'll be able to have much more interesting and creative. Do we do like a set background color? So no, but we do have the text edit already, so that's fine. We actually have access to that because of this. Perfect in SpinBox. Yes, I think this is coming up nicely. It's gonna make my life easier. Or better. Return m underscore text edit. And button up, button down. That's it. We are gonna find the small handful of errors. Yeah, those errors were predictable. We should have avoided that. Wasn't thinking. Hold on a pointer. All right, we literally just moved that function. Now the only places where we set text size. Guess we need to clean. We have some dangling stuff. Sorry about not including those DLLs, by the way. No, yeah, no worries. I'm gonna have to fight that same battle with this game here because of libc. I think, even though I tell it to statically link, it's that for some reason has to be separate, has to be different. Yeah, you can just send those DLLs along. I'll take it for a test drive. I like work games, obviously. Settings scene. That's really the place where we use the most SpinBox stuff. That makes sense, actually. And this should be easy. This should just be all that macro I already wrote. Boom, done. That was the easiest refactor ever. We'll do a pull up, clean, and debug build. Usually I'd have to compile things from source to link that specific library. Yeah. Yeah, that's fair. Although libraries are built in basically two forms. One is dynamic library, which is the DLLs we all love and love. Then there's the statically linked object files. I found with all the dependencies that I've got that there were two options, and if I use the right one and then the linker flag to statically link everything, it would actually do the right thing. Except for libc, which you have no control over, which makes me upset, but you know. Oh no! Okay. We're gonna write in, let's see, we're gonna get this pulled up. I'm gonna write a new macro, which should be fine. These are all text edits. Whoa, 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 what? Okay, wrote a bad macro. F3. So we select this one. Actually, where am I going? Let's go to this one. Now, write a macro, Control X, next error, edit, save, center, F4. There we go. That's easier to record. Okay. Boom, done. Okay, now we need a new macro for this one. Which again, I should have caught on to already. The idea is we do that. So go to the next error. Type in text and arrow, save, center, F4. Oh, done. One more time into the breach. I had to do that with STL with a flag, I think. Yeah. So, and I don't know what your compiler is in GCC. I have to do -b static. I don't know what it is for Clang. I'd have to go look that up. Okay, so basically, yeah, those sizes all look about right. Cool. I think we're done. That was almost half an hour of work right there. Child components exposed. I guess that's it. I mean, really. Yeah, it's dash static usually. Oh, yeah. GCC. Yeah, but then you have to go find all the static libraries instead of the ones that are usually the first ones to pop up, so. Okay, so that was a refactor. And it was shockingly not that bad. So start shell. I thought it would be worse. We're gonna add everything. Git commit -m. Refactored. Compound. Components. To expose the this camera is killing me. I'm going to move my text editor up a little bit and sit up straight. Expose the child components when appropriate. Boom, done. Let's think about what else we got to do. Now, we've already dived into this, and I'm not too worried about it. the performance difference is not a game breaker. But maybe we just start in with scaling sound with time. Do I want to do that? I think sprite sheet animations will be fun. See, I kind of thought we'd have a week for TextEdit. And we got it done in 2 days and 45 minutes. So that gives us a little more time to play. Like, I was kind of thinking, we got all this done this week. Like, this is about profiling, which we've already looked at it once. This is not my top priority. We know the number of draw calls is more, but not by enough that it should cause that big of a draw difference. We did, let's see here. We wrote a whole thing about this. Search for settings scene. There's the task, therefore the notes are. Basically, we removed in SpinBoxes from the update loop and from the render loop. So rendering the integer SpinBoxes costs us more than we might like, but not the other half. We removed the buttons, and those also improve the FPS. So it's all about our render time, I guess. Then we basically went into the SpinBox and said, so this is like the key right here. We removed the geometry update from the button. We removed the state update from the button. We removed the texture quads from the button. We removed the text from the button. And removing the texture binding from the thing doesn't change much. So then the question is, what is it about these two things that costs me so much time? So that's the result of the last time we looked at this. It appears to be render related. It is more draw calls. Honestly, a button is 2 draw calls. An integer SpinBox is 1, 2, 3, 4, 5, 6, 7 draw calls. So the fact that they're comparable. Oh. Okay, so what about this? Integer SpinBox has 2 buttons in it. So if we've just fixed buttons, integer SpinBox itself may not be the problem. So maybe it's just buttons we need to fix. We did try some things in button, but it didn't help. We render a good amount of text in the game itself. Yeah, so like I said, we've already dived into this. I don't feel like it's a top priority now. I just want to keep it on my list to debug later. Or not debug, but chase down. Greetings, JTL. Welcome, welcome. I just have to compile this static. I just have to... Oh, yeah. Yep. Well, you can either, send me a copy of the DLLs or you can statically link it. Either way, be curious to see what your AI came up with and how much you had to beat it to make it work. I feel like we already dived into this a reasonable amount. I'm not feeling like it's key to moving on. Scale sound with time. Now, there is since we only scale time by factors of 2, I think we can cheat quite a bit here. Maybe we do it. Let's just try it. Let's try it. It's not a huge priority thing, but Scale sound with time. Any of the lip-C ones, I can send that as well. I don't know. It only complained about the 4SDL ones. Well, so these dynamically linked libraries were supposed to fix everything. What I'm also starting to find is that just because you have a DLL doesn't mean that it was built with the same compiler and the same flags, which means the DLLs are not compatible. Which means they're not nearly as portable and reusable as everybody seems to think they should be. And then that's a big nightmare mess. Internal static void is back. Welcome back. He's coming with his fleet, his arsenal, his armada of BSD VMs, which contain more VMs. I think I overfilled my mate a little bit. It's too easy to spill. My armada of virtual machines. Yes. Virtual Machine Armada. That sounds like a video game title. You should trademark that. VM Armada. How's your class going? Oh, by the way, Pat, how's your back? I kept meaning to ask on Monday. I give you a weekend to rest, and then I forgot to ask. Back's starting to ease up finally. All right, so scaling sound with time. Sound uses the egg timer, so we do have access to time anyways. So here's the thing. There are two times. We have real time, basically how long we've been since we loaded the scene, and then we have a scaled time. Is there ever a time when I want sounds to scale with one or the other? And what's the default? It's still kinked way better. Yep, definitely 10 times better. I haven't used the 10s unit for like 5 days. Nice. Yeah, I went through a week or two there where I was just flaring up a bit myself and went through the stretches and exercises, icing, heat. It's pretty much all better now, which is good on my side. I have not actually hauled out the 10s unit in a while. I probably should. I also probably should fix my posture. You can tell. Yeah, so for lower back core muscles, there's basically two things. Well, I mean, so there's a bit of stretching, right? Loosen up the hamstrings, the glutes, and the lower back. But for me, the two exercises that made the biggest difference was I think it's called the Cobra. It's where you lay down on your stomach and then you push up with your hands but keep your waist on the ground. Like that puts your lower back under compression. So it kind of squishes the cartilage back in. Like hold it for 30 seconds or something. Or do sets, right? Do 3 sets of 10 or something. Then the other one that really makes a big difference is, I think it's called the bird dog. Your hands and knees, and then you raise opposite hand straight in front of you, and you kick out your opposite leg straight behind you, and just hold that for a second or 2 or 3, and then you lower it, and then do the other one. So it's those diagonal transverse back muscles. It hurts. Oh, I agree. It's terrible. But if I do those two things and a bit of stretching and some ice and heat for about a week, it starts getting better. And then at the end of 2 weeks, like my back pain's been basically fixed up. So I'm not a doctor. Don't take my advice, but like those are the two exercises that actually help me. And they do suck at first, and then it gets better, and then I forget and I don't do them, and then my back flares up again. So it's a vicious cycle. vicious cycle. But yeah, those two, like they give you like multiple sheets of exercises to do, and most of them didn't do anything for me. Those two did. Maybe just doing them before your back gets in pain and just prevent it. That's what I should do. But who has time for maintenance? Maintenance is just terrible. So do I put in a flag that says scale with time? Hmm. I don't actually remember what the egg timer does. I think it's just for reporting. I don't think it's actually used to make any decisions. Maybe do all decisions based on sample count. I can get the duration, time remaining elapsed, play, pause, reset, set the duration. But yeah, it's basically max sample count is what happens. Okay, so the egg timer in this case is just for reporting methods. If I make sound have two modes, one for real time versus scaled time, the egg timer itself would also have to be updated the same way with a flag, which is fine. That doesn't break anything as long as the default is go with scaled time. How am I feeling about this? I don't think I'm too sad about most of this. Because I literally just need to double the number of samples or have the number of samples some number of times, or multiply it by the time scale. Okay, so let's do this. We need the egg timer to differentiate. Bool. Use scaled time. Set use scaled time. Then underscore use scaled time. Okay. We said defaults to true. That should not break anything. I don't think I have copy constructor or assignments. I think that's all fine. Because we do need to track time differently depending on how we're using it. Currently, all of our uses are scaled time only, but we probably should not be able to switch in the middle of a run. That does make sense. Set use scaled time, kind of modify while running. Yeah. Okay, then elapsed duration, elapsed. Okay. Anytime where we reference time, this is where things get a little bit messier, but not too bad. Double T equals time. Let's just simplify this. Ternary equals m underscore use scaled time question mark time, otherwise time real time. Okay, I guess we need to, yeah, real time. That's basically it. That's our lapsed time. Oops. Use scaled time question mark time, otherwise time real time. There we go again. Double T equals that mess. There. Now, in theory, egg timer can handle both scaled time or real time depending on how we set it. BitWriter, I always wanted to learn how physics is implemented in these software like games engines. Can you show me what physics you're using currently and how implemented and how you render them? Okay. That is an excellent question. An excellent question. Sorry to burst your bubble. I'm not using one tiny bit of physics at all in my engine currently. This game doesn't need it. It's one of the reasons I picked this game. Yeah, we can talk about it. So, let's go to our application. Sure, we can reread from there. We're looking for our loop. Right here. So in our loop, we update our time, we update our inputs, we tell the scene manager to run this current scene stuff, we run our event queue, our scene updates and renders everything, and then the window can update. Okay, so you have a sequence of things that happens every time through the loop. So when I say my frames per second is 2,000 frames per second, that means all of this is running 2,000 times per second. Or if I vsync on, then it's 60 times per second. But what you would do is somewhere along the way, and it's probably here maybe. I'd do something like scene manager update physics, and then it's just part of my loop, right? So every time through the loop, before the user's choices affect the game state, physics runs. So that's kind of the top level. Now, what does that mean? Let's go get a scratch buffer. In a scene, you would have a list of physics objects, and there are multiple ways you can implement this. Let's not get into those details. And when you say update physics, it's basically this. For each object in, physics objects, you update your object physics. And what that's going to do is something like this. It's going to say, let's get the total forces, double F equals total forces. So we'll come back to that in a second. What we mean by total forces. Then we would do double velocity 1 equals velocity 0 plus this force times this object's mass times our delta t, our time step. Okay? So the force was applied for 1 frame to our mass, so our velocity is going to change. Then we would say our xy, so our position, equals position 0 times our velocity 1, so our new velocity, times delta t. So how long did we move at that rate? Okay? Then with that position, the next time you render, that's the position it uses, right? Now, somewhere in another for loop, right? So just in any, like, in an update, maybe there's an event somewhere that says, like, when user clicks, then the clicked object apply a force. Okay? Now you can do this multiple ways. Maybe you have a vector or a list of forces that can be applied, right? So let's just add it to the list in increments. Then when we say total forces, it sums it. Or you can start summing forces all at once. So this is like the positional update stuff. And this runs every frame. Trying to think what else. Rotation. Right. So this is basically your basic Newtonian physics, right? This is called a first order Euler integrator. And it's called that because it's literally just an Eulerian method of updating your position and your velocity based on Newtonian physics, right? Now this is not the only way. This is, in fact, probably, well, I can't say that either. Depends on what you want. First order Euler integrator. Now, if you're doing mechanical orbits, what you probably want, so like if you're doing asteroid planetary type of simulations, you probably want a midpoint method. But if you want like high level physics, you're probably looking for a Runge Kata 4, and I might not have the spelling of that right. Runge Kata 4 integration method. So what that means is when you're doing a simulation like this, first order means how sensitive are you to the time step. So if we increase the size of our time step, if we say we're going to simulate every 10th of a second, how is that different from simulating every millisecond, right? And this one, the error increases as the time increases, and they're very first order, right? It's a diagonal line. This also has the downside of, in like an orbital problem, your orbiting objects will tend to gain energy. So your object will spiral out and fly off no matter what. Because it's just not that accurate. Like your time step would have to be really, really small to not accumulate lots of error. Midpoint method does away with a lot of that error. Remember to cut a 4. The 4 is because this is a fourth order integration method, which means if you change your time step, this is not nearly as sensitive. Like you doubled your time step, but it's only 0.01% error added to the system. So if we go back to application, we update our physics, then we say update the scene, and then we render at the new position. That's basically it. This is the heart of a teeny tiny physics engine that doesn't do any rotations. Because you just are applying, wow, I guess right on the spelling? Yes. Thank goodness. Okay, so you're implementing a simple jump. Yep, so if you hit the spacebar, at P0 you'd have higher propelling force. Yep, so you'd have an instantaneous force. It's applied over 1 frame. Or yeah, something like that. There's different terms I've seen. There's kind of 2 types of forces, right? Wind blowing on you versus a jump, which is like an instantaneous thing. So they might differentiate between those two in their engine. Then you update you sum up all the forces on that thing. So maybe you got shot at the same time you jumped. Maybe you want to fling him backwards at the same time he goes up. Fine. So you just take both those force vectors, add them together. Then you update the character's velocity, which you need to store for the next frame. Then you apply the x coordinate, your new position based on your velocity. Make sure you scale by delta t. Your time step says how fast you move. And then, yep. So one force on your character would always be gravity, right? That would always be summed in. Yep. Now you don't have to use like real world coordinates. It can be in pixel, like you're saying. You just decrease your velocity by a number of pixels every frame, and that will work fine. Check if the character's at 0. Yep. Then you don't apply gravity. It doesn't matter if you're at ground. If not, we have another force that pulls down. Yep. Yeah, exactly. So fit writer, that's kind of the heart of it. Very simple. I would start with a first order Euler integrator. There are also another one to look up is called a Verlet integrator. Slightly different, slightly more stable. So let me see. There is an excellent video. Let me see if I can find it real quick. On a comparison of orbital mechanics by a game developer. So, what was it called? Game Math. If I can find his channel. There it is. Jorge Rodriguez. So first of all, this guy's channel is just pretty good. Although I haven't been there in a while, so let's just throw that in the chat. So this guy goes into lots of different math topics. There's one in particular I remember watching that was very good. Oh, where did it go? Like, this is a really good channel for math. And the game developer, let's see. Yeah, modern infinite scroll web pages. I hate you all. Did he call it something about orbits, spaceship orbits? Did he have a all one midpoint? Oh, so actually, yeah. Particle simulation. So this playlist is pretty good. 1, 2, 3. Here are 3. Does he have one on Euler? I thought he did one where he just compared all of them. Under angles. Maybe it's just all 4 of these. Okay, so let me just throw these videos in, because these are really good. So there's your Euler. Here's your let's do Verlet next. Verlet is a pretty natural follow-on from that. Yeah, we'll talk about that in just a second. So there's the Verlet, which is a pretty natural next one to try after an Euler. Here's the midpoint, and here's the Runge cutoff 4. Okay, so for me, what I'm doing is I'm cheating like mad. So you want the bounce jump app? Let's go take a look at that real quick. So let's crank up a thing. We'll pop in and play. So there's that fall bounce. I'm lying. That's not physics at all. There's no physics involved. So let's see what else. This word falling, there's no physics in that bounce. The jump. Where did the jump happen? What do I do if I wrote double click that jump and bounce? I'm not doing any physics there at all. So let me show you what I do. What's it called? Game scene. That's a good place to start. Let's do the things falling onto the screen. So next level, if I'm using animations, we clear out a bunch of state. Where's this animation? Animation to drop. So I have 2 stages of animation. Okay. So I create an animation, which literally just says, for this amount of time, we're going from 0 to the height of the frame. So we're off the screen by the height of the frame. This is where we start. And then over time, we're going to move everything down by that amount. Okay? And the amount we're going to move it down is between 0 and delta value. So that's just a straight vertical drop. So what this animation does, have you seen the animation yet? Let's dive into that just a bit. When we start, we just start a timer. That's it. During the update of an animation, we get our timer. We clamp it to 0 to 1. Okay, so our animation is only designed to go from start to finish, not further, not less. This is called your parameter. This is your t. So it's always going to be between 0 and 1. So if you were running from 0 to 3 second animation, then t is the current elapsed time divided by the duration we expect to go. Make sure it's clamped. Then we parameterize it. Otherwise, it's just between 0 and 1 from here to there, right? It doesn't look very natural. This easing curve is what's making that bounce. So let's go look at ease. What happens is, by default, if you don't ease that t with anything else, it's basically linear. So let's go look at the linear. Where is it? Here, linear. We just return t, right? So it's not changed in any way. It's if you plotted it, it would just be a straight line. Actually, let me see if I can find anything. ease.h. I'm pretty sure there's a link here. Yes, this one I think has some good animations. Yes, this describes pretty well what those animations look like. So linear just says, between 2 points x and y, x naught, y naught, and y1, x1, y1. Just go in a straight line between the two, right? But if we do things like quad in, quad out, quad in, out, we can make it look like you're accelerating and decelerating. So it looks a lot smoother. In fact, like this is like my most used easing method to parameterize my t. But you have other options, and one of them is an elastic option to elastic in and out if you want to overshoot and bounce back. That's kind of a thing. Bounce. So what you're seeing when things fall is the bounce out method. So if I go to bounce out, it basically says, if you look at that easings.net, it says we're going to go partway there, and then we're going to bounce, and then bounce less, and then bounce less. So you see that for the first 4/11ths of the animation, we just fall. Then we fall over the complete height too. Then when we hit the bottom, between the 0.4 and between 4/11ths and 8/11ths of the total time, we do this little bounce, bonk. Then between 9/10ths, between 8/11ths and 9/10ths of our total time, we do another little bounce, and then we finally do the last fall, right? This is the last bounce. So it's a 3 bounce, 1, 2, 3 bounce after a fall. It uses up part of the time. So that gives me a parameterized time. And then we just apply it, right? Here's how I apply this parameterized value to these positions, or to this value, or to this position x, y, or to these colors. So all my animations have that same shape. So that bounce. So it's here, like this one has an elastic in, right? So if I swap 2 letters here, let's get some letters so it's maybe a little clearer. If I swap J and L, they actually preload and then go. And I don't remember if they overshoot and come back. It's kind of fast. But anyway. So I'm not doing any physics at all. It's all animations using parameterized t to give that character. Hopefully that helps. What I'm pretty sure I'm going to work on for my second game is going to have physics, or at least game physics. This one, no. Single player game, for example, where you freely move in a world. These would just be variables, like a parameterized current state, and you use it to update the world environment for every frame. for information you currently and naturally will be in the next frame of the world. Yeah, yep, exactly. You have information about your current state, and then you apply whatever changes to it, and then it is updated, and that's where it renders the next frame. That is the heart and soul of simulation, animation, physics. The difference is my animation system doesn't care about physics, doesn't care about mass. It only cares about the elapse of time elapsing. Physics would care about a bit more. So yeah, no, those videos are great. I really like the Jorge stuff. If those are too deep to get started, like he has a lot of simpler stuff at the beginning of that playlist. Yeah, it's really good watching. I like the Jorge Rodriguez Math for Game Developers series. Okay. Now, what was I doing? Egg timer. Egg timer, we just made split. So we can use scaled time or real time. So sound can kind of have the same thing, actually. Use scaled time const set use scaled time void bool scaled. We do that right after the destructor. I try to keep the functions in my header file in the same order as they appear in the implementation file. Maybe it's just me being OCD, but I think it's better if the order is as expected. If I go to the next function, it's the next one that I already expect to see. But yeah, start with just a simple Euler integrator. You'll learn a lot just by doing that. Okay, a couple of pass-through methods and we're done. Start. I have to think about where to put all this stuff because when we because our duration is not scaled. And when we start, we have to tell the system to scale it. Ooh, no, our duration has to be more dynamic than that. Oh, okay. Let me think about this for a second. I think I'm going to go on a short restroom break. While I think about it. This gets a little bit tricky. Okay. Now, I was thinking initially that we would put our duration scaling at the start of the play sound. But it is entirely possible for us to change our time scale in the middle of a sound playing. That is a thing we can do. Therefore, we can't do that. Which means what? How do I feel about this? I need. Because the only other place we could put time scaling is in the stream callback. This is like as we go through the sound, it keeps asking us to load up a buffer. And when we go to load up a buffer, this is where we say data sample count. Ooh, and these waves are going to be interesting. Okay, all right, let's think. This actually gets complicated. What I'm thinking right now is up here near the top. We update our max samples based on time. So max samples is greater than 0. So we can play sound forever, right? Or while the button is pressed down, we don't necessarily have a maximum number of samples computed. If it's greater than 0, we have to ask the egg timer, are you using scaled time? Then we need time scale. Oops. What did we call it? What is our time scale? And then what? We have to compute our new max samples. Which is, oh no. Do we need to store the last? running at double time, we have to use half the number of samples. If we're running at quad time, we have to use a quarter of the number of samples. If we're running at half time, we need twice as many samples. Okay. So, where do we use max samples here. And this is the one we care about. That's one. And here's the other use. Are we done playing the sound basically of the two cases? Which means I think what we need we compute one outside of this, then max samples divided by the scale. Cast that to an integer, not Python style, thank you. Max samples. That is not quite right. We need int remaining samples equals max samples minus data.to sample count. Then our remaining samples. Oh no. Here's the problem. If we're running our sound, and it starts somewhere, and runs some number of samples, from 0 to x, it would be trivial if we knew that the time scale wouldn't change in the middle. So if we time scaled here, there we go. So if we went from time scale 1, then halfway through we changed to time scale 2. Then we have the amount we've already run, plus the amount that remains, but the remainder has to happen at the new rate. Where this gets complicated, if we knew we could only change once, that would be trivial. What happens if we change from 1x to 2x, then back to 1x? And I don't know when I hit this point, one, what the new thing will be, or if I'm going to change again. Hit my tongue. Okay. Total samples is just the number of samples we've written out to the buffer. Oh no. Oh, PCM sample offset. Good. We did have that separate from the number of samples. Oh. Sample count divided by 2 max samples. No. This does take into account left and right. Okay. So we have how far have we gone, which would be this chunk. Here's how much is left, which would be this chunk. And we estimate how many more we need. Maybe this is the wrong way to go about this. I'm having new thoughts. This is part of the fun of discovering things and not being a sound engineer, not knowing what I'm doing. Just kind of got to think through the problem. Or a DSP expert. PCM sample offset. T is computed here. But sample count is only done in real time. These things are managed separately from that. Okay. I'm liking that better. I have a question about how NPCs are generally implemented in complex games like GTA, for example. The physics and behaviors of NPCs in games are basically calculated from a pseudo-random number state at the beginning of the game. Changing this value basically affects the whole system, right? Like if you set init state, whatever, you'd have 4 NPCs in Los Angeles beaches doing something, someone in Cali walking somewhere else. Sure, playing going to New York, totally different. Yes, meaning you can change or influence the behavior of the NPCs via this random init state. From that point on, this NPCs will interact with the game's environment after initialization. The physics would have been parameterized, the NPC would render accordingly. Okay, yep. So it's similar to the bootstrap process and operating system. You can think of it like that. Like after initialization and lock screen, just basically behavior as per how you interact with it. Like it has predefined logic that supports and how to handle it if you say open an app or install or whatever. Okay. No. It's thinking about complex systems is a valuable exercise. So let's take a look at a game level. Step 1, you initialize, then you enter into an event loop, then you have a cleanup phase, right? Now, during initialize, your NPC could load from file. It could RNG initialize, right? And the NPC has a certain number of parameters. Let's create a very simple NPC like it has a, let's just say that everyone is a blob and you have a mass and a color, right? You can get those values either from a file or from RNG. And by RNG, like you could have a palette of 16 allowed colors and then randomly choose one of those. Or you could randomly generate the red, green, and blue channels for your blob, right? And that doesn't matter, really, because all you're doing is getting initial values. Once you have those initial values, your event loop updates the NPCs at some point. Maybe that's physics, maybe it's behavior, all sorts of things, right? Anything you think, or user input could affect them, etc. Now, the important thing is that what's inside this event loop, this update function says, given the current parameters, here's how you behave. So if all we have is mass and color, maybe your blob's speed is dependent on the color. The more red you are, the faster you go, right? So it's a balance of red versus blue. And maybe green is how high you jump, right? In which case, each of these little blobs is going to move differently based on the random color they got. And it will look different, but it's the same physics engine. It's the same behavior script, but it just is looking at different values and running those through the math. Does that make sense? So this update loop is really the secret. If you want to add a new parameter, let's say that instead of color and size, right? What have we got here? We said we started with mass and color. Let's just get this out here. Parameters. Maybe your blob has a mass and a color, and color determines speed and jump height, right? So down here in this update loop where it says because of its behavior, the blob wants to jump, it looks at the color to see how high it can jump based on that parameter. Okay, so you've parameterized this data. The NPC is defined by this list of parameters and nothing else, because the behavior is determined inside the event loop. Okay, let's say we want to add another one. Let's say we want to add hunger. Well, inside this update loop, it's going to every frame reduce your or increase your hunger, and then the behavior model, when it sees that your hunger has exceeded some threshold, which again can be random or loaded from a file. You can start with random hunger, so some blobs get hungry sooner than others, or at a different rate. Like maybe it's hunger and hunger rate, right? I mean, you can simulate all sorts of things. Hunger rate, how fast you burn through your energy, or maybe your hunger rate depends on how fast you're moving and how many times you've jumped and how high, right? So your hunger level would go up each event loop until it crosses a threshold. Then the behavior of the slime says, "Oh, we are more than 50% hungry. We should change our behavior to go look for food." Or so all it is the event loop determines how the parameters are used, and how you initialize those values kind of doesn't matter whether you load it from a file. Like in StarCraft, right? The campaign, every initial condition of the whole level is set in stone. Otherwise, the campaign would play out differently. But yeah, for like GTA, it just loads a bunch of parameters from RNG, and this update loop is very complex to handle all those parameters and choose what to do and how to behave and where to render. So does that make sense? So hopefully that gives you an idea that initialization, whether it's random or not, doesn't matter to build your core engine. In fact, to test, I would say don't use RNG. Use a loaded file or a hard-coded array of parameters to test the behaviors that you want, right? Is the physics behaving the way I want? Are the behavioral scripts making the decisions I want? You would actually want those hard-coded for testing. But then eventually you want to test the RNG, but like your system is parameters and functions that operate on those parameters. So hopefully that helps. Yep. Yeah, basically. Okay. All right, back to it. Okay. So one thing I'm thinking about is inside here, having a loop for, okay, we can hard code and cheat. Option 1. Sample count. Let me just trace through and see what sample count all does. That's not what I selected. Thank you. Hmm. So I can think of ways to cheat. Clever stuff. I used event loops in the past, like e-polls and polls in Linux networking, but I never thought of this way, and it can be used in games this way. Yeah, at the heart of every game is an event loop. In the heart of every operating system user interface, there is an event loop. They don't always expose it to you. It's often a fixed pipeline. So, like, again, looking back at application here, this is what I decided the event loop looks like. It can look like lots of other things. So if I was on I've run bare microcontrollers, so there's no operating system. You write a literal while loop in your main function, and it dispatches actions depending on whatever you choose, right? And one of those things can happen outside the event loop, which is called an interrupt vector. So if somebody pushes a button, it triggers a GPIO pin on your microcontroller. The microcontroller detects that and sets a bit inside of the interrupt vector. And you say, when I see this in the interrupt vector, go run this other function. And that function will set a flag, which I then, in the next time through my event loop, I pick it up and do the thing. You don't want, at least in microcontrollers, to run big complicated functions in your interrupt vector handler, because that can interrupt other operations. So what you usually do is your interrupt vector just sets a flag, and your event loop handles that update. But yeah, event loops are everywhere. Event loops are wonderful. Event loops are our friends. Yeah. Unity decided on theirs, and it has some similarities to what I've got here. There's obviously has physics and like a pre-render pass and then a post-render pass for doing all of the post-processing on the image. But that's all part of what they decided happens in their event loop. So if you write a simple blob simulator, that could actually be very educational. And here's a very basic event loop and how it works. Okay. This is getting a little bit mind-bendy. So I need to keep track of real time versus scaled time. Right now, this only operates in sample time. And we could easily, if we were just running at double speed the whole way, we could easily just scale our our t parameter, for example. Easy. In fact, firstly, this probably belongs inside here. And secondly, if the egg timer uses scaled time, we just update our TP, divide by equals time scale. Which will change our pitch. At halftime, we double our yeah, and that still doesn't tell me how to know when I'm done with the sound, since we can change our playback speed at any time. Any audio experts in the audience? I probably can work my way through it, but so if we're running at half speed, we literally need to sample our T twice as often. and had half the T. But how do we know when we are done? Right now, this is the check. If we've just told it a duration or greater than that. So if we are doing double speed, we want to sample through this twice as fast. If we're doing half speed, we want to sample through this at half the rate. So we don't change sample count. So this is all power of 2 stuff. We're filling up frames per buffer. We know we only operate at powers of 2. Maybe that's just where we start. Maybe I'm trying to be too generic, because I was thinking we're gonna have to like interpolate between sound audio points and average weighted averages. If we just know that we're doing powers of 2, it simplifies things a lot. Maybe what we do use scaled time. We'll do something. If our scale is double time, quad time, we actually want to skip over basically. But if it's half time or quarter time, this sample count gets much more complicated. Is that bad? Maybe we're okay with that. Sound outage. Sample count. Double. First of all, does that break anything? Make that a double. Cast that to an int. What else does it break it? What's it called? Signal data. M underscore signal data. Got egg timer. let's just make sure some sounds play. Some sounds play, others do not. I'm not hearing any of the ticks. Hmm. I clearly didn't really have this one all figured out when we started this project. Range. Now this sound isn't playing at all. So where did those sounds go? Hmm. Egg timer has a boolean. It is true. Use scale time, set use scale time. We're running, get our time. Okay. I don't currently see any issues here. That should not affect anything yet. We moved this, but cycle sample index and T only used. Commented this out, so that shouldn't have an effect. Created a local scope. Maybe if we just descope that for now. This is just a pass through. Huh. None of that should make any difference to the sounds we're currently playing. We'll test it anyways. Okay. No, not that one. This one. Invalid stream pointer. Why? What did I do? What happened here? Oh, okay, I better know what's going on. Whew. We added a parameter to our memory footprint. I bet that's what's killing it. We need to clean OGCC, my old friend. Error messages stop making sense. It's time for a clean and rebuild. They still don't make sense, then you have a problem. Okay. So we don't work with powers of 2. Therefore, if we're running at quad speed, I need to skip 4 and just take the 1, which probably won't sound very good. So we'll make an update after that, but our sounds should be working. Okay. So that did not affect anything. Good. I hate going down a side road and then discovering that I just didn't do a clean and build. Okay. La la la. So we're doing a data sample count on every single case statement. So let's factor that outside of our switch. Okay. Divide by 2. Then up here, inside of our loop, I'll just increment once per frame of audio. I think that will be better. Just make sure we didn't break anything. Okay, things generally working. Okay. So proud lines, no M, C or H. Ultra demon, I, P or S. I know. Oh, here we go. Always nice to find those. No, N was in. Okay, so I didn't break sounds doing that. Pulling the data sample count out. So if my scale here, double S equals 1, if data use scaled time, then S equals our scale. We know it's a power of 2. And it's between 1/4 and 4. So we're going to fill this buffer half as fast or 4 times as fast, but we're going to get 1 sample count per frame. Running at half time, quarter time. And interpolate these points from the previous. Get 2 or 4 samples. It's just different behavior if we're trying to scale up time or scale down time. Because in one case we have to interpolate between points. In another case we want to combine and average multiple points. So what do I need? Running at half time, step through T. By 1/4. But then we have to go through, so scaled time, scaled T, T divided by S. So if we're somewhere in a sine function, doesn't matter, and we want to move through that sine wave half as fast. So the scale is, so let's multiply. There we go. So this is our scaled T. And our scaled T. I figure out how to put this inside of a loop. If we invert it, this is what we want to do. We're going to go for something around this. If we're scaling down our time, we want to basically do this math and not put it in. But still count the sample count, even though we did not put a value in. we scale up time, we want to move faster. We want to put more of this stuff in the buffer before we add our sample count. No, it's a factor of 2. Two. Guilty. Just put it back to T real quick. We have a scale factor. If it's 1/4, you want to move slower. One, 2, 4. It's one we go through the loop once. Or what? Our scale time is 1. We go through this once and throw it into the left or right channel. If we're playing 4 times as fast, we want to walk through the PCM sample offset much faster and the T much faster. Through the PCM sample. Let's just narrow my scope here. Say that our time scale is 1 or 2 or 4. make it sound faster, we add all these things together. We start at 0, and we sample out 1 or 2 or 4 of these things. And after the loop, OV divided by equals scale. This is the right value. What was this one? If, okay, so that's fine. One, left value, right value gets 1. Yeah. I wonder. Maybe there's something I should just Google. Maybe it would be faster. Let's see here. How to scale sound playback PCM. Now everything's going to tell me what PCM is. Thank you. Oh, that they want to scale other things. Hmm. Not very helpful. Okay. Okay. Play. If our scale is 1, 2, or 4. We average based on how many samples it grabbed. Shove it into the channel. This is an else. One, two, 4. So grab up 2 sample counts, average them together, shove them in together. This is for positive increments. Everything is 1. I don't think I'm going to break anything this way. Sounds okay. Okay. Seems okay. So what we need is in Sandbox. We need a time sound test. Init sound time test. Sound time test. Sound time test. Test. Sound time. Init replay test. Init replay test. So we're going to pop this in here. Comment all this junk out. Okay, so what we need is a sound on a button. Yeah, we can, you know what? We can keep this dead simple. Okay. Okay, first thing we need is a sound. I think everything else we can do just with keyboard. Okay, so we're going to set file. Probably chime. During the update, if input get key pressed is key pressed. There we go. Input key space time sound dot play. Okay. down. If you'll key up, then time.set scale times scale times 2 divided by 2 it's greater than 4. And if it's less than 0.25, clamp it. Okay. We can make this easier. No, I lied. If we pressed up or we pressed down. Time scale. Time scale. Anything else? That's basically it. So we've only thought through the positive scales right now. Okay, init sound plan test. Update. Render. Timed sound test. Okay. If I capitalize these characters, it'll probably work better. Let's go into our sandbox. Up, up, down, down. Okay, seems to be a thing. Spacebar should play the chime. Okay, moment of truth. What if we played it double time? That was not terrible. I could believe it. So that's how we scale time up. There's one. Oops. And it does just seem to change in the middle. Okay, that was not bad. So if we're gonna go to sound, the other thing we could do, well, just leave it at that for now. That's if we're playing it faster. If we play it slower, we have to do something else entirely, which is we have to put in 2 or 4 samples per sample. To 4 samples per sample. So here's this. Yeah, well, that's fine. This means as long as we have an integer number, it's less than, we want to invent new samples per sample count. Okay. Cool. Sped up. Now let's see. Slowed down equals equals slowed down equals false. If we are doing this, slowed down equals s less than 1. Samples per sample equals 1. Samples per sample equals if we're slowed down, then we do one thing, otherwise we just take that. I think what we want here is integer of 1 over S. So if we're running at halftime, we want to put in 2 samples per sample. Which is where this comes in. If we're slowed it down, if we're not slowed down, we do this. And here, if we are not slowed down, this is what we do. Okay, if we are slowed down, then we'll put our left and right channels. We'll put that sample count. Okay, so we output our sample channels and LV equals 0 and RV equals 0. So if we're slowed down, we're going to put this sample in, but we're not going to count it until we've popped out of that loop for over and under sampling. Let's see what that does. What? Samples per sample? Oh, fair enough. Samples per sample. Okay. Head into our sandbox. Now, we're going to run it. Sounds okay. We run it sped up. We run it super sped up. Okay, everything sounds good there. Now, half scale, and it blows up. Perfect. And it's probably because of this. If we're slowed down, we need to do something else. If slowed down, we do something else. Basically, we have to interpolate between PCM sample offset and create invented data points. So let's put the logic everywhere just to be consistent. Okay. Now what we want is the previous sample offset. So if previous offset equals left and right. Minus 2 minus 1. then if this is our first frame equals 0, so this is our first frame, and we just increment these by 2. Maybe we can just hard set them. Why not? Equals 1. Okay. So we have a previous sample and our current sample. We are not going to use the previous sample. We're going to use two or four interpolated values. This does get a bit more complicated, and this does assume only powers of 2, which is fine for now. Okay. Then we get a double T equals our count. So if it's 1/2 time, we're going to get 2. So 0 and 1. Count plus 1 over our time scale. So if our 0.5 times the scale. If we're slowed down, count plus 1 times our time scale. So if we're doing 2 samples, that is a 1/2 time scale. So we have 0, which is 1, 1 times S, 1 times 1/2. But if we go to 2 times 1/2, so then if it's 4/4, then it's 1/4, 2/4, 3/4, 4/4. So there we go. Now we can interpolate between the two values. LV equals this probably needs to be plus equals here to be consistent with everything else. We would probably have to scale the T, but we'll take a look at that. Okay, so our left value is going to be equal to int 16T left sample left to 0 equals this thing. Well, let's make it a double. Our previous left offset. Right 0 is our previous right offset. Left 1 equals this. Right 1 equals this. Okay. Now we interpolate between the two. Therefore, our left value plus equals our left 1 minus left 0 times T plus left 0. We do that 3 or 4 times. Is that it? We'll try it out. It made sense in my head at the time. So let's go to our sandbox. Sound 1, 2, 4. 1, here's 0.5. Oh, no, nope, okay, did not like that. 0.5. Assertion failed. I don't think that makes any sense. So here's the thing. If it's our first frame, and we're just at the same place where we were going to be anyways. Right, left value, left 1 minus left 0 times t. So basically take the width, scale it down, add the offset. If we are slowed down, we don't add a sample count. If we are slowed down, we add the sample count here. Otherwise, this is where we write the values. I think that's logical. Index. Oh, we're filling that index way faster. Right here. Right here is where we are not. No. But we're just running out of X. Not running out of index. If count not equal to 0 plus count or index, because the other index will get hit anyways. If index greater than frames per buffer rate. That might not be perfect. Okay. Normal time still sounds normal. Half time does not sound normal. Whoa, uh-oh. It just kept playing other sound data. The idea is we want to put in 2 or 4 samples per sample. So is that not what I'm doing? If we're slowed down, we got a previous thing. Basically, we're inventing sound points in between these points. at normal speed. Let's go quarter speed. Sounds like it's playing at normal speed. We're slowed down. Get the previous point. Figure out what our t is. Sample the previous points, sample the current points. Interpolate. So at some point, t is the full width plus that, which just leaves us with left one and right one. Whoa, okay, hold on. This needs to happen inside here. It's all about counting indices, isn't it? Let's see. So, sandbox. So, sound speed 1 and 2 seem fine. Let's go to quarter. Samples per sample. Left channel, right channel. Yeah, putting in 2 or 4 per sample count. That's the theory. Or which slow down, do these things. Index greater than thing, 3. Travis, time for bed. Have a wonderful evening. Yes, we'll see you tomorrow. I'm actually shockingly close, I think, to having the scaled time sounds. Let's see, select. There's double. Sounds fine to me. 0.5, 0.25. It just isn't detecting the end. Also, sandbox scene. I would like to know how long the time ran in elapsed real world time. Which I don't know how I feel about things here. Yeah, underscore time sound dot is running. Not do those. Okay. What I really want is to know how long this sound actually played in real time. Which there are 2 or 3 different ways we could do this. Let's go back to here. Egg timer, scaled egg timer, and a real egg timer. Dot set use scaled time true, which should be the default, and use real time false. Or set use scaled time false. I don't want egg timer, I want stopwatches. Oh, stopwatch doesn't scale. Well, let's go do that too. Stopwatch. Egg timer.h. And then probably need to do that anyways. Okay. Easy. And I never received time. It looks like that. Pause. Okay, so everywhere we were getting time. We're now getting a choice. Okay. Setting scene. Not setting scene, sandbox scene. These are stopwatches. Stopwatch. Stopwatch. So if we are in here, then m underscore scaled stopwatch is running. Scaled stopwatch dot stop. Else just reset it. Same thing for the real one. Then we start them both. M underscore real stopwatch dot start. M underscore scaled stopwatch dot start. Okay. Then if m underscore real stopwatch dot is running and m underscore timed sound dot is not playing, then m underscore real stopwatch dot pause, m underscore scaled stopwatch dot pause, note real sound time 0.3 float, scaled sound time, scaled factor, and last but not least, sound duration. Okay, so we should have time scale. We should have time sound dot duration. We should have m underscore real stopwatch dot elapsed and m underscore scaled stopwatch dot elapsed. Okay, so every time we hit the spacebar, we should get this information when the sound is complete. And it should all make mathematical sense. It would make more sense if I put parentheses around that thing. Okay. Okay, we'll do a full clean. Who knew that making sounds playback slower would be harder than making sounds playback faster? Still got like 2 hours. There's no way we're not getting this done today, right? Helps that it's all integer divisions, though, for sure. Okay, stopwatch. Oh, we didn't copy that. Ah, timer. Right here. These one and this one. Okay, timer with stopwatch. Easy peasy. Oh, okay. Run it. Now, in theory, if we play a 1-to-1 time, we get a printout that looks normal. The time scale factor is 1. Our sound duration is 2.9. And it plays out for 2.9, and that's, there's some buffer zero filling that happens, so that's fine. If we go to doubles time, and in the real world, it took about half, 1.474, which is half of this. So that makes sense. If we go all the way to quad time, I assume that's about a quarter of this. So if we go through here, we can say divide this thing by 4. UXE 0.753 change. Yeah, okay. So our real world clock is agreeing with all the rest of it. Now, that's maybe not shocking, but it should take like 5 seconds. And instead, it's just playing through the remainder of the other audio. Or if we're playing our current buffer into the other buffers, that is about double. So the time management looks right. Interesting. If we go all the way to quarter time, that's going to take like 10 seconds, which means we're going to get a ways into this one before it stops. 11, 12. Oh, it's times 4 of about 3. Yeah, so that's about right. So time is being calculated correctly. The samples are being counted correctly. We're just not updating from the buffer correctly. Okay, good to know. So, sound. I could swear this would do what I wanted. Should interpolate new samples. I think we're close. Super close. What are we doing? What are we doing? I need a new gum, that's for sure. Hmm. Zero fill remainder of buffer. For the average of these sampled, the samples. Samples per sample. Play interpolated samples. Maybe here we need to do a minus minus index to offset one from the for loop. This is going to dump in 4. Then this for loop here also increments it. That'll be 5 per loop, which does mean we need to subtract 1 at the end of all this. Undo the extra index increment introduced by the for loop. Because here we just let the for loop do it. Here we did it ourselves. Break out if we run out of buffer. I need to print things. This is going to make a big mess, but load down samples per sample. Just the samples per sample. Okay, so we want, where we slow down, slowed, other. What's our time scale? And our samples per sample. Then in here, our count, we're going to get our T. Interpolate T equals this of from here to there. It's getting to be a very long thing, so let's break it down. Interpolate our T, imputed, the empty is our previous L offset, and our left is 0. Our previous R offset, and right 0. Plus 1, left 1, previous R offset plus 1, and right 1. Should yield 0.3f. So let's see here. Index value, left, right. Index value, left, right. Outputs a left, right is LVRV. This is going to log a ton of stuff. We can just look at the first few and probably get an idea what's going on. If we remember to put semicolons to things, and parentheses or commas. Life is hard. Too much syntax. Okay. This is going to log out a ton of junk. But we're going to do it at the slowest one and say go and quit. Quit. Jeez. Woof. Debug. Here we are. We really just want to look at the first few frames. We're slowed down by a factor of 0.25, which means we need to sample 4 samples per sample. So we're interpolating 0.25, 0.7, 0.5, 0.75, and 1 from here to here, which is 0, 0. That's fine. Let's take a look at this. 0, 1, playing from 1 to 2. The very first frame, this is wrong. Okay, we need to figure that out. But I think it's time for a snack run. This gum is getting old. Okay. And we are back. Here's what's going on. We're trying to play back sounds at a rate other than the one sampled. Playing our sound back quickly, faster, more fastlier, as the grammars have it. It's not that hard. We've got that part done. Well, as far as recorded sounds, we've not touched yet non-recorded sounds. Samples per sample. Okay. Let's do this. If LV not equal to 0 or RV not equal to 0. I would like to at least see some actual data without having to scroll through tons of junk. And then there we can say data point to sample count. Oh. Bool logged equals false. We did log something equals true. Therefore, if we logged something, then m underscore, that's your data, point to sample count equal data point to max samples. And break it. So hopefully that just stops the sound before we get too annoyed with it running on forever. Okay. So I'm going to slow it down and hit go. Okay. 2. Interpolate. These are not 0. These are basically all the zeros in our sound at the start of the sound buffer. So we need to count equals 0. If the f absolute value is greater than 0.0, 125 maybe? Or fabs of this guy greater than some number, 0.125. Let's try that. Come on. As doesn't exist. I suppose that's fair. How would it know that I meant? That is not all the button press. Okay, and go. I would like to. Why is that 2? Modulus D is our count. I would like to get all the way through the count. Or we break. Oh, right here. Sandbox. Slow down and go. Boom. Huh. Plus 2 and plus 2. So these are actually plus 2 because we've added 1 and 2. We're breaking out of the loop at a time when we need to check for the end of the sound. Hmm. Interpolations look correct. 0.75, 0, 1, 2, so that's correct. These indices look correct. Going from 0.165 to 161, we're 3/4 of the way there. This is a reasonable response to that. So it's not detecting left and right channel. Don't increase our sample count. After we've done that 3 or 4 times. Oh, interesting. That's fine. Data sample count greater than 1,000. Data sample count less than 1,010. Or not 10 samples. And each of these would be 4. So let's just do 5, which would put me at 20 printouts like this. Lines of output. Okay, so let's just get a few more samples just to see what's going on. 1,000 samples in. Good old audio. I wish I was better at audio, but you know, just not. So if we crank this down to that, slowed by a quarter, we're doing 4 samples per sample. We're interpolating 4 samples per sample. 0.25. Those are all zeros. That's really not that interesting. Right, let's go out like 10,000 samples then. Oh, let's see here. 44,005. Let's do that. That should put me about a second in, right? 44 and 44. I just want some useful audio data to look at here. Slow it down to a quarter. Spacebar plays the sound. Okay, so it's interpolating values. -0.10 to 9. Positive puts you. Oh. I see, said the blind man. This is why we print stuff out. This here is the problem. We're incrementing these for every interpolation instead of interpolating each interpolation. At the end of the for loop, we increment this bad boy twice. Which happens when we add the sample count. If we're slowed down, and if we are playing an actual sound. Or, alternatively, we can put it in here. If count equals 3, increment by 2. We were moving on. We took a point, another point, and then interpolated them, but we moved on before we interpolated the other 3 data points. So we were moving on at regular speed. This we will only increment on the last count of counting. Equals samples per sample minus 1. Think we get rid of this. And this. And that should sample me 4 sounds per actual sample. So go in here, we can slow down to a 1/4 second. This should take about 12 seconds to play. And done. Perfect. And we can change our time scale as we go. So if we go back to halftime, perfect. And it's done. Okay, that is not bad. Which now means when we do a replay, whoa, that's, oh. Let's go back to sandbox and put our time scale back to 1. And then let's go to high scores. Replay this bad boy. Okay, it sounds normal. We will start the replay. Bring it halftime. Anyway, so if we reset, nice. Chunk. I think I cheated and that's going to break this, but that's fine. Okay, so sounds now scale with time. Therefore, in game scene, when sounds playback scales with time speed, put this back in. Here we were waiting for a duration. We want to wait till the sound is complete. And we do that in 2 places, here and here. So do that, do that. And now that should just work. That was the whole point. I don't want to calculate the duration. Oh, I don't even want this one. I don't want that one either. Wait a second. This one. We're adding this to the subsequence, which we say we need 6 steps of. So subsequence.set. 1. We really don't use that many subsequence steps, do we? That's not what I said. There we go. animation, play start sound, set immediate. Okay, so this one, we set immediate, that's 0. We set a start sound, that's 1. We set a play, well, 3 is play animation, 4 is do until. Then we added the extra weird one. So I only really need like 4 of these. And now we run a replay. Do you have a better replay than that one? Do we? Go to marathon? Sprint? We don't have one. Okay, so we reset. Go back. We need to make a quick high score here. So okay, forwards, TRAAED. So let's get those real quick. Let's do TRA. TR, not A. T, not RA. Not TRA. Okay, looking for contradictions. ED would have to be in. This is a contradiction, so this is not a good assumption. E or D, therefore M and O have to be out, therefore I is in. And there's our contradiction. So it has to be A and R. Oop, not that one. Not S, there we go. Not I, therefore E, therefore not M. Okay, BD, logs, jacks, waxed. Okay, so we can get rid of everything except JKWX. JKWX. Oh, nice. That was actually not bad. Okay. Lunch, toads, ultra demon lace, rhino, proud lines. Okay, we get to do that. Lace, rhino. Interesting. ON. TR, nothing interesting. Lace, rhino, STUMP. Well, it can't be both S and T. UMP, not interesting. Proud lines, M or T or H, not helpful. So let me think here. I mean, we can probably logic our way through this with ultra U, T, not R, U, not TR, not U, TR. Looking for contradictions. Rhino is not even close. Okay. U, R, N, H goes away, and there's a rhino. It's a problem. So it's RT. Which oddly doesn't get me very much. Ultra Demon, HIPS. Okay, interesting. Chips has to have one letter in it. So H and I can't both be out. So it can't be an I or P or S. Therefore, it has to be in CH. CHIPS. So it has to be H or I. Therefore, N or O are out. So M is in. No N. Oh, what? RT. Laced rhino chips. CHIPS has to have 1. I cannot eliminate both H and I, so P and S are gone. O is in. N or H has 1, so I is in. So M is out and N is in. Rhino, Trony. Intro, of course. Intro. Alright, whatever. Okay. Now we're just gonna fail prime lunch. Toads ultra. Chips laced rhino. Stump proud lines match. Inked human under earth. Oh, okay, great. We get our high score. And we can watch this replay back on some speed. Whoa, those sound distortions are pretty fun. Okay, what we're most interested in is the level transition. It wasn't working before because it was waiting for that sound to finish and it wasn't finishing in the time allotted. Oh, perfect. The level transition works. Great. We can now watch replays at quarter speed, or at quad speed or quarter speed. Oh, cool. We've done it. We did it. Look at that time ticking away 4 times normal. I think we're just calling that done. Let's go clean up game scene. Those 2 views have to go away. That goes away. That goes away. Those go away. Easy. Make sure it still compiles. But that actually didn't take as long as I thought it would. We're only at 4 o'clock. Let's go to our journal. As discussed above, sound now plays scaled with time scale. This will only work well with integer multiples, i.e. 2, 3, 1/2, 1/3, etc. I think any integer number will work. Any integer fraction, because we invert and integerize it, right? Yeah, that's probably true. And sound. We should add a note to where we scale things. This one. Sound time scaling will only work well with. So one of the reasons we had this flip-flop here, so we can turn it on or off, is that when we're playing music, we don't want it to be affected by time scale. Like if it's a background song, with integer multiple scale. For example, oh, did I do IE? IE is in other words. EG is for example, right? EG 2, 3, 1/2, 1/3, etc. Okay, we do want that in the code because I'm going to go back months later and look through that and be very sad because I will not have remembered that. But that's it. Git status, git add everything, git -m sound can playback scaled with time. Egg timer and stopwatch can do scaled or real time. Default scaled. Set up the journal as well. As part of this F worked, egg timer and stopwatch have a flag to indicate that they should use real time or scaled time. Note that animation does not expose this flag, though it probably should. Okay. So that note's added. Do we just do it? Do we make animation expose that flag? Animation. Because I think it just runs everything off of an egg timer just the way that sound does, right? Egg timer duration. Yeah. So we can do this easy. Animation. We can make animation run off either way. Animation dot H. There we go. We're going to steal from egg timer. Egg timer.c. Animation.c. Do I have copy constructors or anything? I hope not. Good. Then we just need to copy these two functions. Slap them in. Okay, timer for animation. This is the thing right here. If it's not running, animation cannot modify while running. I think that's it. That should do it. Oh, not that way though. Actually, incorrect. Animation does not need this flag. We just pass it through. Did we put that in stopwatch as well? We just pass it. No, stopwatch doesn't need this one. Sound does not. Sound. Did we put that flag in there? Bunch of hard coded. I don't think we did. Yeah, good. Actually, yeah, we literally just rely on the egg timer, so animation can do the same thing. Like that. Return m_egg timer dot, does it use scale time? underscore egg timer dot use set use scaled time. Boom, done. Right, just compile that, make sure it runs, and then we'll commit all of it at once. If I can remember all the curly braces I need. Okay. I said kill. There we go. I'm gonna run it real quick just to make sure the animations run the way we hope they do. Play. Huh? Kind of an interesting word here, but we're done. The animations are all good. Quit. Animation also exposes this flag. For this effort, take timer and stopwatch have a flag to indicate they should use real rule or skilled time. Huh. That is an odd place to break some of these lines. Anyway. Okay. Shell get status, get add everything. Now we can do the get commit. Animation should also be able to select which time to use. I haven't tested it thoroughly, but you know, it's all good. Oh, boom, done. Not bad. Actually, that was not, it was not as painful as I thought it would be. Once I got in through the fast stuff and then stubbed in the slow sound, it seemed more doable. And then I spent way too long on the slowed down thing because I forgot I was double incrementing that, or well, multi incrementing that PCM offset. Okay, with that, what are we working on now? We've got an hour sprite sheet animations. Or we've got 1 hour. Practice mode. Do we do practice mode while we're sitting here? We got 1 hour. I think we can do practice mode in 1 hour. I don't think I can do sprite sheet animations in 1 hour. I don't even have a sprite to try against. We are so far ahead of schedule now. I've only got like these two things that are nice to have, but not necessary before we start doing our real refinement pass. This list of refinement items is going to grow as I write down things that annoy me. Like currently in the playback, the time scale strings are not great. So we may discretize the time scale in that interface. But again, that's all like refinement, polish, etc., etc. Maybe we just go for a practice mode. Let's do a practice mode. I've got time for that, right? Maybe. And it all starts in game context. We don't have it open for some reason. Game context.cpp. I've got 2 hours. No, I can't get this done, right? And we need game context.h. Play mode. We're just adding practice in here. golf. Practice. Solve a single word practice by solving a single word. That's basically it. As far as game context is concerned. So the next thing is main menu. Just look for everything that says golf. Practice. Golf. Underscore button practice. Practice. Set tooltip. Okay. Throw practice into the mix. Pardon me. Golf. Practice. Okay, so I should lay everything out and have it in the main menu. This has nothing to do with the gameplay loop, which will have to be updated in the game scene itself. So we run it. Oh, I forgot we added stuff. So we probably should clean and debug. We added memory to our footprint. I don't know why that breaks GCP. I think a build should just work, but you know, who am I to judge? I haven't finished my compiler yet. It doesn't do all the cool things yet. Okay. Just about like kind of expect. The warnings all make sense. Boom. Oh, practice golf. Okay. The spacing's a little off, but that's fine. Does this not have a tooltip? Does anything have a tooltip? There's golf. There's practice. My description is garbage. Jeez. Context. Here we go. No high scores. There are no high scores for this mode. Oh, we did a full clean. We didn't need to do that. Oh well. Yeah, sprite animations tomorrow. I did not think we'd get this far today. That's encouraging. Okay. Oh, we forgot to change the layout. We need to change the rectangle. Small space. There we go. That fixes it. Oh, we did another clean. Why would I do that? We just talked about this. So we do kind of want those enumerations. Maybe it's good that we're fully rebuilding. Okay, that layout looks more correct. Practice mode, sprint, marathon, golf. Okay. There are cases where the tooltip doesn't pop up. Okay, well, in the compilation, find that high score scene doesn't handle anything. It's in context, play mode, practice. Break. Okay, where's the next one? This one. Oh, high score entry. There we are. Is it better? Practice and default. Whatever else we had should just say false, I guess. By default, that makes sense. Okay, the real meat of this is when we go into game scene. Easy. You get 1 out of 1 word. I'm gonna say you can have a timer in practice mode, right? Play mode equals so that sets the time label up. Okay, this gets more complicated if this or play mode equals in context play mode practice and there we go. Sprint. Practice 1 of 1. I don't really want level to be word here. Okay. Next, we're searching for sprint. Practice. If we're in sprint mode, okay. Or play mode practice int level equals 6. Our top level equals 1. If our level equals our top level, stop, finish the update, etc. You do win. Okay. What else do we do? Sprint or golf? Use the answer was whatever. That's fine. Or golf. Or golf. So basically, if play mode is not equal to marathon, if you're not in marathon mode, failing a word ends your run. If you're in marathon mode, you go until you fail. You are considered a loser if you didn't solve at least 1 word. Okay, next. Sprint. Or underscore play mode equals in context play mode practice. Play mode equals in context play mode. What's it? Practice. Okay. So when we end the game. Okay, replay modes. If play mode equals game context play mode something or other. Play mode practice. Off. There we go. If we're in play mode, we do not replay anything. Okay, so means we need to consider the different modes. If we are on update, if we're in playback, so we can ignore that one. Trender or back clicked. If we're not in playback, okay. It has to be in record mode. Does that make sense? Play mode record. It's not equal to playback. That's going to be a pattern we're going to have to run into. We are in record mode. Oh, nope, nope. We're not in playback mode. We have it off. Same thing here. We are not in playback mode. Okay. We're in record mode. Let's end the game. Play mode equals record. I think that's it. So that skips all that. We're in playback mode, so that's fine. It's playback specific. 79% of the way through the file. Play mode equals record. We're not recording, so that's fine. If we're in playback mode, ping, or not. We're worried about being in an off mode. We are not worried about that one or that one. All right, that is it. We should do a full clean. We just swept through a bunch of stuff. We're just adding a whole new game mode, just, you know, in the last, really only been at it half an hour. But I have 2 hours. Like, are we gonna have to start sprite animations today? This is a little bit absurd. This is when you find out if your designs have any merit at all. The fact that I had enumerations, things are cleanly spelled out in lots of places. It was actually pretty easy to add the new mode. We still have a couple of small changes to make, but we will get to that. Built even. Okay, so our questions are, does it play in every game mode? Does it play back in every game mode? The actual testing of this could be a little bit exhaustive, but here we are. Okay, let's remember what we're doing here. For Ultra Demon, or no CH, IP, or S, place rhinos. U is TMU. Interesting. Those go away. N or O, therefore not D. O or A, there's a O. Therefore no A, no N. So there has to be an L. Okay. Oh. O M molt. There we go. All right, animations all seem to be working. You're not breaking anything in level transition. Toads, ultra, laced, right, crowd lines. Waxed jacks. Plink. What? That's not a word. Heart. Oh, interesting. We could probably solve this now. Dang it. I was just trying to finish out the level, but by finish out, I mean lose it deliberately. WX. U is in, it's F or G. Therefore, it's probably guard. Oh, shoot, we lost. Huger. Cool. So there's a playback. If we go into this playback, it should run. Okay. Okay. So that'll work fine. If we go into practice mode. Oh, it died. It died. Oh, we're doing an assertion somewhere when it probably needs to not. Or, yes, okay, so replay 591. When we call thaw, we're getting a thaw when we're not in record mode, but we didn't get a freeze. Interesting. Aw. But it got a freeze. Okay, so some of these assertions in replay have to change. Not playback. Not record. Or not playback. Playback only. Not playback. Not equal to playback if our mode is equal to record Okay, record. That's fine. We should never ask for a header or finalization or completion or header size or any of this junk. Freeze thaw. We're not in playback mode. If we're in record mode, we actually do something useful. Oh, no. Just if we're in record mode, we're good. Logging. Okay, play this replay file right. We have to be in record mode. Validate. Yeah, replay should not do anything. Yeah, I think that's it. So let's compile. Yes, we'll do it full clean. Why not? Hey Pat, I got that word list from some GitHub repo that just hosted for people that need it. It has like 2,000 words in it. Okay, cool. Yeah, what I want to do is like just do a diff, which I have the file and I have the one you sent me, and I just want to do like a straight up diff and see what words are different, just for my own education. I think mine has 33,400 words in it. Now I think I got a bunch of words that are like of European spelling with the OU that you and I as Americans don't use, or there are some words that are more like French. Like this is an English language, so why do we have this in our dictionary. So I'll have to be checking through that eventually anyways, but just as a diff, just be like, oh, here's what's different. Could be interesting. So we're gonna go back to our playbacks. Our high score, playback, crank it up, and go. So playback's fine. I assume the level's gonna roll over just fine. Well, that says render. Interesting. Practice mode. Oh. We have elements laying around up here that need to get not shown. So I think we have some logic when we do our layout. Okay, problem one. The timer did not start. Huh. C or E. Flogs has to have one of the letters, but there's no guarantee that BD has the other. M is out. FG or WX. Um, hmm. Worms. There's W, there's an X. And it is G, not F. So we can just lose this now, it doesn't matter. Chips, stump, match. Under think whale. Okay. So we lose our practice word. Go back. That should not have a new replay. There should not be a replay. There should not be a replay of this. I said turn it off. Oh, okay. Okay, I know what's going on. Main replay. Recall init. If we turned it off, we just didn't do anything. I think off just looks like a playback in the case of initialization. Game scene underscore time label. If we're in sprint mode or practice mode, it shows up. If we're in sprint mode, we set it up with text, color, and alignment. It's the animation. Update time label. Placement, fine. Set text size, fine. So, update time label. Okay. Equals sprint or underscore play mode equals in type play mode practice. Okay. And there were some other things where it was the playback. Maybe we should get playback. I guess, right, not equal to playback. It's fine. Next level. Finish the level. Back reset. Not worried about that. Next word. Where are the two layout? Probably in here. If replay mode is playback. Thinking these are the things that are. Give me once. If it's record, okay, so if it's not equal to playback. There we go. That should fix that. Oops. If I can spell right. Okay, that should fix the last two issues with the gameplay. What I'd be more curious to see is, do you have words I don't have? That would be the more interesting problem, I think. Or it may just help me find and eliminate French words like amour, M-O-U, A-M-O-U-R, which, when I found that one, I was like, really? That's not English. Okay. Okay. We play practice mode. 492. Header. Oh, interesting. Header. If it's not playback. If underscore replay mode equals replay mode record, then we do all this. Right. We are whittling it down. Replay dot mode. Okay. Play practice mode. Looks good. There's none of that junk up here for elements not being hidden that are not being laid out. Got our timer. Does it work? Boom. Proud lines. MTCHENIS. B. Logs. X. Wax. There we go. It's W or X. Nice. Did it in 34 seconds. That time rounded differently. I'm not that worried about it. Cool. Practice mode now goes in, and this replay. Oh, okay. Let's do a quick loser marathon mode here. Run. And then we do things and surrender. So that should be our latest replay. About 10 seconds worth. Bounce toads, bounce, bounce, done. Okay. So that's our latest replay. If we go to practice mode, we do something. ESDP no M. E vlogs waxed. So it's WX or B or Y. WX, B, Y. Waspy, wisp, whips. So no W, it is X. So is it B or Y? Huh. And we surrender this one. Pikes is interesting. That. Is that a weird spelling? I don't know. Pikes is a small round container used in the old Catholic and Anglican churches to carry the consecrated host. Oh. Well, I guess that's why. I do not know Catholic stuff. So replay should only be yep. So it did not save a replay of my practice run. Perfect. Okay. So there's one thing I want to add to practice mode. That is that you should be able to select how many letters, how many word guesses you get. So if you want to practice a 10 guess word, you can skip straight to it without having to work your way through the other 5 guesses. So I think that goes into in context. All these colors and things are. We'll make this, what's it called? Practice guesses. Game context. Boom, there we go. Now game scene. If I see practice. Oh, not that one. If see next level. Books. So literally all I have to do is change oh, dang it. Dang it, dang it, dang it. Actually, no, we hide our level, right? Do we hide our level? Level. Hmm. Level. So this is probably not actually the best way to do this. Let's mark this to come back. I want guess count greater than guess count and guess index. Okay. So that should check for guess count. X, Y, Z. Index less than guess count. There we go. Let's see if that renders anything correctly. We put everything in terms of guess count instead of level. We can override whatever we get before the first frame. So if we go to marathon mode and it dies, full clean, I guess. Out of snacks, I guess it's back to gum. All right, gum it is now. It's just dying. Okay, it's probably where we're rendering the books. That's really the only thing I've changed. Boom, explodes, backtrace. There is no backtrace. Oh, it's an assertion failure anyways. So what is the guess count at this point? should see. What's really fun is this is like the last little piece to add to this one, and it'll be done too. We've still got an hour left. I don't think we'll have any troubles finishing this one off. An hour is an eternity. So much time. Sometimes. Oh, guess count is 20. I see. Yeah, so quit. Less than 20 minus guess count. I'll bet that fixes it. Yeah. Oh, I'm still logging out guess count. That's rather silly of me. Right, we're going to cheat, make sure the book's rendered properly. Play cheat. Go cheat. Let's just keep going, I guess, for a little bit. Okay. So this is our 10. This is the lowest number of guesses you get, so. That's good. All right, quit. So that's part 1 of this. Part 2. After we go to the next level. Ooh. Not sure if we can do it this way. Okay, next level. Compute the new guess count. Okay, if game context if play mode equals game context play mode, and we want to do practice, we do one thing, otherwise we do this. Guess count equals game context practice guesses. Okay. Okay, so if we go to marathon mode, seems to work. But if we go to practice mode, it should just be 20, which we can then test. Practice mode play. Looks about right. In context, let's just make sure it works. 10. Super easy. Practice play. Got our 10 guesses. Nice. Let's go to 13. This is not possible, but because it goes by 2 guesses per level. But I'm just curious now. Boom. 1, 2, 3, 4, 5, 6. That's 12, and the 13th. It works. So game context. Put that back to 20. Main menu. We're going to add a thing to it. And the thing we'll add is a SpinBox. Int SpinBox underscore spin practice guesses. Okay, main menu scene. In our initialize, we want to set it up. We want a range from 10 to 20. We want a value of game context practice guesses. We want a step. Do we not have a step? Ooh, okay. All right. Int step const void set step. Int step. Set value, blah, blah, blah. Return him underscore step. Interdecker int underscore step. Index m underscore step defaults to 1. Anchor plus step and minus step. Can I disable edit? We will not touch that right now, but we will write ourselves a note. Do, I don't know what this counts as. We check that. We know this should be done, but we haven't done it right now. In SpinBox. Can we disable keyboard editing? Can we disable typing? Focus. Okay, whatever. Interdecker takes our step value. Then what else? Let me think. So main menu, set step 2. Okay, then M underscore button practice. M underscore spin. Right here. M underscore spin. Set a rectangle. That must be the same width. No, height. X plus big button height. Plus small button width plus a small space. At the same height, this width needs to be more like maybe a small button height in width. We'll just see what that looks like. Spin dot text edit text. Let's see how it looks. Value, then step in SpinBox. Oops, we do have that inverted. I thought we had covered that. Okay. Let's make that 14. Oh, we probably need to clean build, huh? Oh, okay. So we need to add a small label to it as well. Come together pretty nicely. I didn't think we'd have time to do a practice mode today, but honestly, we're cranking through it pretty quick. Now, okay, it comes up with 14. I want that wider. 75 is clearly too small. Maybe a big button height. I think that X with an offset. Integer. For X equals. that. Big button height plus a small space. We might as well add the other thing while we're in here, huh? Text underscore label practice guesses. We have other labels that we're setting colors on, maybe? Something like this. Not centered will be well, vertically centered is fine. And that. Set rectangle. Have X, Y button, height button. Okay, so this could be like a small button width. Set text size, small button font size. I'll make this clean and go. Okay, getting close to having practice mode in and done. I love it when a plan comes together. Boom. All right. Guesses 12, 10 to 20. Very nice. Not bad. We want to practice with 16 guesses, but we haven't hooked it up yet. Main menu scene. The handler or something. What do we are void update practice guesses. Our integer SpinBox takes a value changed handler, which is a void int. That looks right. So this will be game context practice guesses equals value. Let me just register that. which were spin got set callback. Guess we're just std binding this. Guess that's it. And that might just work once we get through the compiler. Compare with substitution, blah blah blah, static insertion field, wrong number of arguments to pointer to number things. Set callback. Oh, I need a placeholder. Where's a placeholder? STD placeholder, is that what it's called? Placeholders. Colon underscore 1. There we go. Boom. 20 guesses. Boom. Is that what I set it to? Set it to 14. Set value. It's an order thing. Could be, I suppose. There's the 14. So if we play practice mode, we've got our 14 guesses, 20 minus 6. We go all the way down to 10. There's our 5 by 2, so that's 10. We go all the way up to, let's go 18. 20. There they all are. Okay, so we can now guess any number of words we want. So gain context. We will put that back to 20. I think that's a reasonable default. We're not going to save this in our output, in our game status. It's so easy to change. That's right next to it, and 20 seems good. I think that's it. I think we're done. That whole feature, leaving us with 40 minutes. I don't know what I'm going to do with 40 minutes. Comes up 20 by default, and it just works. Okay, so there's 5. Place rhino, not quite enough information there. Ooh, interesting. Human. Earth. Ooh, E-A-R-T-H. Worms, oh, interesting word. Still not that much information, really. P, I, and E, those are probably my best guesses here. So P, I, not E. Oops. P, not I, E, not P, I, E. Okay, looking for contradictions. There's our contradiction. Earth needs 3. Yeah, lots of contradictions. Bad guess. Okay. H, not D, T or A, so not U, which means C has to be in, A has to be in, not T. H. Okay. So it's working. This is great. Sweet. Journal. Fully implemented. Oh. To do. SpinBox should not, or this SpinBox should not allow focus keyboard edit. Like fully implemented practice game mode. No high scores, no replays, single word only. No, can choose a number of guesses between 10 and 20 by 2. That's basically it. Not bad. That was pretty straightforward actually. That's where you know your design finally is paying off. Implemented practice game mode. Boom, done. Oops. Check the box. Okay, box checked. 40 minutes left. Well, maybe not full 40, but either way, that's really good. We did a full up tech new feature. We did a full up new practice, new game mode. Nice. I'm gonna move this as a lower priority. Let's see here. Maybe just polish. Polish. Replay time scale in fractions, not decimals. Bug. Sometimes a main menu tooltip stops working. It's just like things we need to fix and finish and polish later, eventually. This is not a high priority right now. Boom. Not bad. Sprite sheet animations. I kind of want to do that, but 40 minutes, 35 minutes. Not very long to work on it. What do I have that I can do for 30 minutes? 30 minutes. You could fill in some fluff in the about scene. That's not the worst choice. What is this? This game is an homage to Wordbreaker, game made by Bob Scully, 1984. Put on map when I was a youth. Here are some links for more information about the original game. Word deduction game are 5 letters long. You have no duplicate letters. You have a limited number of guesses to deduce what letters you need. And guess the correct word. For each word you guess, the number of correct letters is given. No positional information. There are 4 play modes. Who made it? Yeah, we'll fill that in later. Maybe not why. What's another thing? So one thing I want to do is let's see here. What's this called? About callouts. Resources. It was designed to be as to use as few dependencies as possible. Here is the full list. We can get straight from the shell. Oops. I would like the text to line up here. I don't think I have a good way to do that. So we need to visit this thought. Okay. For fonts. Following fonts. Are used. I have an FAQ somewhere. Not that one. Fonts. Nope. Here we go. Right. Francois 1. Okay. Okay, so that's some good information to anybody who cares about technical details. I would like this to lay out a bit better than it probably is going to. So maybe we just don't try. Okay. Make sure it looks okay. About. Blah, blah, blah. Resources. Yeah. We need to make this font size bigger too. It's small even for me, so. Made it. Yeah, we're gonna make those bigger. About scene. big font. 45. Okay. Make it like 60. This one like 45. Let's see how that looks. Ugh. Oh, that's a little bit easier to read, except in word wraps. I need to make it wider. Wider. So where we set out our title width, W. Where are we calculating W? Just make it a tiny bit wider. I want to make this a bit wider, actually. Big button width. Scale width 300. Okay, that's better. Okay, who made it? Resources, yeah, that's better. Okay. Oh, spacings. Spacing, this text spacing is garbage. I actually want to change text. We had this concept of line spacing, right? Lines spacing. Ugh. Text.hpp, set line spacing. There it is. Oh, I see why. Okay. Yeah, we're gonna make that 1.25 by default. Okay. Oh, that's a little bit more readable. I'm gonna go 1.5. Yeah, maybe 1.5 for this one. I think in general that's not bad. So, about scene. I'm gonna just go to text body 1.set line spacing 1.5. Save it for 2. There we go. Okay. Oh, nice. Oh, that's better. That's much better. And how does this look if I make the screen bigger? So let's see here. If I put this over here, and minimize that. Then I can show the whole big screen. So we go huge Normicus back, go to the about scene. Yeah, that scaled up nicely. Okay, that's way more readable. Way more gooder, way better. Cool. All right, what else do I want to say about scene? Okay, so this one is, what is this game? So, what? Who? So everybody I owe credits to. Maybe this is more of a how. Why? I don't know. Hmm. Put in some links, why not, right? Plug my own stuff. Eventually I have a web page. That's a thing on my queue and my list. Let's see here. Week. Not sure why I put that 83 in there, but that's fine. Let's see, where's the thing? What is going on here? Can't I? So I set up a channel. Let me see. There we go. That one. What else do we put in here? Maybe one of these things. Let's see here. Oh wait, I know where to get this information. Maybe. There we go. A little web page or something eventually. Just filling in the old about screen. Come to them. Wait a second. Okay. Bunch of stuff. Resources. Why? Okay, well, I don't really need the why right now. No. Project. Build a game. No engine. Other than the dependencies listed on the how page, I wrote every line of code myself. It was very educational. The scope was carefully kept very narrow. Very narrow, so it wouldn't spiral out of control. The longer plan is to make another simple game, not quite as simple, and call it and refine what I learned from the first game. Probably another homage to an 80s or 90s game I played as a youth. After that, we have the wherewithal build a game of my own design, of which there are many ideas written up in my notes. Okay, let's just see how that looks. So I'm just trying to fill up the space, throw some things in there that might end up with there, and we're just gonna. We kind of wrapped up all the big tasks we wanted to do today, plus some. So we're kind of filling out our about window here. That's the notification that we're towards the end. How was it made? Blah. Okay. That's probably not how you spell wherewithal, is it? Wherewithal. Yeah, it's only one L. Shame on me. It looked funny when I typed it, but. Okay. I think we're in really good shape. That was quite useful today. A very productive day. So, going to our to-do list. The next thing is sprite sheet animations. We're going to start that on Thursday. We'll probably not finish it this week, although, I mean, maybe. And once we get the sprite sheet animations done, it's all about refinement, cleaning things up, making it user-friendly, look better, more polish, all of the polish. We're going to add more sounds. We're going to add more animations, clean up. I don't think there's any animations I need to clean up, but maybe we'll simplify animations. I don't know. Art. Yeah, the art sucks right now. That's because we didn't spend any time on it at all to speak of. I do need some music though. Luckily, I have a sister who's very musical, so we'll see what she wants in return. Okay. I think we're just gonna call it there. Like anything else I do is add more stuff to the about. Added more notes to the about. See, and updated the layout some. Updated about scene. Boom, done. I think we're just gonna call it there. Like anything else I might want to try in the next 10 minutes, it's not gonna be enough time to get started. So I think I'm gonna bomb off there. Tomorrow we'll start sprite sheet animations, whatever that means. We'll work our way through it. And yeah, thanks for joining me. Thanks for everybody for all the comments and the questions. And yeah, hopefully we'll see you tomorrow. Remember, Friday is compiler day, so not tomorrow, but the day after. I'm having a hard time keeping track of my days of the week this week. Yeah, so that's it. Thanks. Cheers. Have a wonderful day. Bye-bye.